Okay, MYP Physics, welcome to the last week of electricity, okay? And so I decided to simplify things a little bit and just end electricity with a basic understanding of how electrical circuits work, okay? And more importantly, going through just common components that we would find in basic circuits. And I'm sure you've seen some of these, you played with some of these, I'm sure in middle school, in grade 6, 7, or 8, when you played around with circuits with Miss J. All right, and now I just want to go into a little bit more detail on how they work. Okay, so the objectives for the lesson today is to really understand the role and function of common components in simple electric circuits. And the components we're going to talk about are batteries, wires, and what I call spenders of electrical energy. Okay, so in a circuit we always have spenders, and these spenders are resistors, light bulbs, motors, electromagnets, speakers. Those are just some examples. And we're going to limit our discussion to these things. Okay? So for the remainder of the year, this is the only type of circuit that I'm going to talk about. And in grade 11, we'll go back and we'll cover the complicated ones. We'll get into a little bit more of an understanding of how they work. In physics classroom, you would see things called series circuits and parallel circuits and combined circuits. I'm going to leave that out for this year. Okay, but you're welcome to go and read about that and understand it. So here is a basic circuit. This is what I'm going to expect you guys to understand. In a basic circuit, you have a battery. You have wires connecting that battery. I've already shown an example of this in a previous video. You have an ammeter. An ammeter is a device that's connected inside of the circuit to measure current, the flow of charge. And you have a voltmeter, which measures the electrical potential across any component. So this voltmeter is attached on the outside of a resistor. A resistor is a component that resists the flow of electricity and creates heat or limits the amount of current. So my voltmeter is connected on either side to measure the change in potential energy across that resistor. Okay, the change in potential energy per unit charge. And that's my voltmeter. Okay, so an ammeter is put into the circuit, a voltmeter across any of the components that I want to see the voltage on. And here is my battery. The long line is positive, the short line is negative. Okay, in physics, the current goes from positive. In chemistry, it's the real current where we talk about the movement of electrons. All right, and in a previous video, we talked about Ohm's law. And Ohm's law describes the relationship between voltage, current, and resistance in a circuit. That's the relationship. So the greater the voltage, the greater the current. The greater the resistance, the weaker the current is going to be, okay, in a circuit. That's Ohm's law. We played around with that in the last class, okay? So in this video, we're only going to focus on the battery, okay? And I'm going to make subsequent videos where I'm going to take each individual component and we'll talk about it. All right, so what is the role of the battery? The battery supplies electrical potential energy to a circuit. Okay, these are 3 things that I'm expecting you guys to know if I'm going to give you a test. Okay, the battery is the supplier of electrical potential energy. In addition, it creates an electric field to move charge through a circuit. All right, so the electrical potential energy moves the charge through the circuit. It gives it that driving force to push the charge around the circuit. And the energy associated with the charge is transformed in the circuit. It can be transformed into heat, light, okay, movement, and we'll see that later on. Okay, and you can see this picture over here. If you ever tried that, often teachers would tell me if you put your tongue against a battery, you can tell if it has juice because it makes a little sizzle. I wouldn't suggest doing that, but here the video is showing the change in chemical or electrical potential energy is causing his eye to twitch, and that's because electricity makes your nerves fire, and that's why you get that kind of buzzing feeling when you attach a battery to yourself. So the first question that I want to talk about is, how does a battery store electrical potential energy? Okay, remember, electrical potential energy is the work done to move charge in an electric field. Okay, so naturally what I would have is atoms inside of that battery. Okay, so we'd have these little circular atoms you can imagine inside of that battery. Now this isn't 100% true, but we can imagine all those atoms are neutral and they all have protons and electrons, okay? And what has to happen is the battery uses a chemical reaction. So a chemical reaction is performed inside of the battery to move, for example, the electrons move in that direction, and the protons, well, the protons don't actually move because they're stuck inside of the nucleus of an atom. But just for the sake of simplicity, you can imagine that the negative charge moves down in that direction. It uses the chemical energy of the chemical reaction to do the work to move the negative charges onto this side, and the positive charges stay on the other side. And to keep them separated, your battery has a membrane in between. It has a material that blocks that charge. So once I've done the chemical reaction, all my negative charge is stuck on this side and it can't flow back. And all my positive charge is stuck on this side and it can't flow back. Okay? So this membrane doesn't allow those charges to flow back. Now what's going to happen is I have electrostatic repulsion on both of these sides of the battery. It's locked. So there's a lot of electrical potential energy stored on either side of the battery. And the only way that that electrical potential energy can be released is if that battery is connected with a wire. As soon as I connect a wire, these charges can flow because they can't flow through that membrane, and they can neutralize these charges. Okay, so that's how a battery stores electrical potential energy. It uses the energy of a chemical reaction to move charge, and it stores the charges on opposite poles of the battery. So what happens when we connect the terminals of a battery with a wire? Okay, so I want to draw this little membrane in here again, and draw these little positive charges in here again. All right, and we'll draw these negative charges on the other side. Okay, if I connect a wire, which is a conductor, to this battery, if I connect a wire, which is a conductor to that battery, okay, the wire will immediately sense the electric field stored in the battery. Okay, so here you see a cross section. I cut out that little section of the wire. Immediately when you connect those two terminals, all right, it's a conductor, so it allows the movement of electrons inside of it. If I just take the cross section of that wire, it immediately senses a positive side on this side and a negative side on this side. And what happens is the battery supplies electrical pressure. Okay, the battery supplies electrical pressure. Okay, this side can feel negative charge building up on the other side, and so the electrons in here are getting repelled and they're getting pushed by the pressure caused by having all that negative charge stored on that side. So this negative charge on that side of the battery is going to push all the electrons, and all of them are going to push. They're going to apply pressure to the electrons to move them through the circuit. Okay, and they're attracted, these electrons would be attracted to that positive side. So they're all going to start to fly and move as soon as that wire is connected. Now, if it's a fresh battery, I have a lot of electrical potential energy, and these electrons will have more of a push. Okay, as the battery dies out, there's more neutralization happening in the battery, and that push becomes weaker and weaker and weaker. So one way we can talk about in grade 10 is that a battery, the electrical potential energy of the battery, supplies electrical pressure that pushes the electrons through that wire. Okay, and as they move, we get a flow of charge, which is a current. All right, so that's what happens immediately when you connect the wire. Okay, these electrons will want to flow to the other side of the battery. Okay, now another thing that we got to think about the battery is that the battery is a source of high potential energy. All right, and as that energy flows, that energy has to be converted into something. Okay, so as these electrons move, that energy is going to be converted into something such as light or heat, and we're going to talk about that. So why does a wire and a battery get hot when electrons flow? Okay, well, this is what we're going to talk about. We said that all that potential energy that's stored in that battery has to be released. As the negative charges start to flow, it's going to, you can imagine that negative charge has high energy. Okay, and as it flows through that circuit, that high energy is going to go down to low energy. Okay? It's going to go down to low energy when that electron makes it to the other side of the circuit. So where does all that energy go? Well, that energy is going to be released in some form. So whenever electrical potential energy is released as that charge is moving through, that energy has to be released in the form of light energy or heat energy or mechanical energy. And how much energy is released? Well, that's what 9 volts is. 9 volts says that 9 joules of energy per coulomb of charge is released, okay, when that charge flies through. So for every coulomb of charge that flies through this circuit, 9 joules of heat energy would be released if this is just a wire. And why is heat created? Well, we talked about it when we talked about resistance. When that electron flows, it bumps into atoms. It ricochets. And when it bumps into atoms, those atoms start to vibrate, okay? And as those atoms increase their kinetic energy, so does temperature, okay? So wires are going to get hot. The faster the electrons move, the wire gets hot, okay? Inside the battery is also going to get hot because charges are moving inside of the battery and bumping into atoms all through the battery, okay? So even the battery has some resistance, and the charges moving inside there is going to cause the battery to heat up. The faster the current, the more collisions happen per second, the faster it heats up. So we have to be really, really, really careful when we create high currents, because high currents create a lot of heat in the battery and in the wires, which can create a fire. All right? So that's basically it. We talked about batteries, and here's just a little video showing you how batteries die. The end.